All right, well, welcome back and thank you for coming back for this afternoon session where we're going to get into the meat of our program, which involves our 10 pitches. So we are very excited to have you. My name is Joey Clark, and I'm the program director for Starts, which is the kind of the placeholder for this event in particular. So when it comes to Starts, Starts is a program that aims to bring together ventures, early stage companies together with some of the problems that are most pressing in the DoD. At NSIN, we have a national network that we find ventures, and we kind of pair them together with venture capital and also with academia to bring together some great problem solvers. So we're very excited to be here, and it is my pleasure to MC the second half of this program. I get the biggest pleasure in introducing my managing director, Morgan Plummer, with the National Security Innovation Network. He has been a great mentor and friend of mine, and he has very much facilitated in our group a fantastic way of problem solving when it comes to defense and national security. So Morgan Plummer, as I mentioned, he's the managing director. He also was the senior advisor for the Undersecretary of Defense for Personnel and Readiness, and I'm happy to turn it over to him.
Joey, thanks so much for the great introduction and for the kind words. Really appreciate all of the work that you personally have done in putting together this program iteration and in pulling together all of these great startups and all of these great partners from throughout and among the DoD to make sure that we have a terrific event. Grateful to you, grateful to the work of Jesse Geip, who's been on the ground there in our Pacific South region based in San Diego, and the entire NSIN team that I know has been a crucial part of pulling together this terrific event on behalf of our DoD partners. In terms of the National Security Innovation Network and NSIN and who and what we are, I know that everyone's kind of coming off the lunch break, and there's already been a long list of speakers. So I'm going to try and keep my remarks relatively brief, but certainly want to take a point of privilege and just talk a little bit more about who NSIN is. And really, we are a program office within the Office of the Secretary of Defense that is really focused on fundamentally changing the way that the Department of Defense solves problems. And for us, our underlying theory of the case, the thing that undergirds everything that we do, is this idea that if you want new solutions, then you have to bring in new problem solvers. And if you don't do that, if you don't take a different perspective, a diverse perspective, a perspective that pulls in the folks who wouldn't normally come into national security service in one way or another, then you're fundamentally leaving things on the table. And I think when you think about and explore interesting new dynamic technologies like 5G, this is a really great example of the kind of technology that the DoD absolutely has to master in order to maintain its comparative and competitive advantage throughout the world, but is absolutely a technology in which the private sector and largely the startup community is outpacing some of our own R&D efforts. And so it's for that reason that I am really excited to be able to participate in today's event and really excited at just the terrific and really interesting lineup of startups that we have that want to contribute to the DoD in solving this particular problem set. I want to be sure to thank our partners. We've got folks on from that you're going to have heard, some of whom you've heard from already, others of whom you're going to hear a little bit more about after I speak. Our partners at NIWC PAC, our partners at MCTISA, our partners at Naval X. There's a real thing that's almost experimental in the way that NSIN approaches collaborative problem solving with new problem solvers. And without a willingness to accept risk, without a willingness to experiment, without a willingness to venture forth into unknown, undiscovered country with new types of partners, this thing doesn't happen because NSIN doesn't solve its own problems. We work with our DoD partners to solve their problems by pulling in non-traditionals like the startups that are about to pitch. And so I really want to thank our DoD partners for the risk that they've been willing to take and assume in exploring these new and different ways of solving problems together. And finally, and maybe most importantly, I want to thank the ventures, both the ventures that have that applied to be a part of this pitch competition and those that are about to pitch, because you're joining a really important thing. You're participating in the national security and the national defense of this country. And that's a sacred communal trust that we hold together as citizens. And I am really personally grateful for the different way, the different type of service that you're willing to volunteer for. Now, I understand, because I'm not fully altruistic myself, that there are prizes involved and benefits on the upside that you can gain from this experience. And I hope that the best among you will be selected. But for raising your hand, for volunteering, that was a choice. That was a choice that you made, and I'm grateful that you've made it. I'm grateful that you want to partner with our DoD friends and partners to solve this critical technology challenge area for the Department of Defense. So with that, I think I'm going to turn it back over to Joey. But once again, let me thank everybody for their involvement, for their hard work, and for their willingness to serve and collaboratively solve these problems together. Thanks so much.
All right, well, thank you, Morgan. And I hope that all of you see why I'm so excited to go to work every day, because working with people like Morgan and Jesse really show that service to this country comes in many different forms. So thank you very much, Morgan. Now I'd like to introduce Tom Collins with Now PAC, who's a principal investigator. He has single-handedly helped me expand my understanding of what 5G is and how it can be very much used in the future of defense. So I'm excited to pass it off to him.
Thank you, Joey, and thanks to all of those participating and attending today's events. To give you all out there some context, I'll briefly outline the 4 problem areas that we asked the companies to address with their submissions. Problem area number 1 involves autonomy. As highlighted earlier today, the promise of autonomous vehicles is readily apparent to military leadership. And using 5G as the medium to connect those vehicles, traffic infrastructure, and orchestration and control points has obvious benefits. However, in an expeditionary environment and analogous to a domestic rural environment, ubiquitous 4G, 5G coverage cannot be guaranteed. So problem area number 1 seeks to identify technologies that enable the seamless transition of connected autonomous vehicles traveling through 4G and 5G coverage areas to non-coverage areas and then back again. Problem area number 2 involves 5G enabled sensors. We're seeking sensors that rely on or necessitate those 5G benefits, such as high bandwidth and low latency, but can also operate in intermittent 5G environments to include caching data when they're completely disconnected. Acceptable applications include, but are not restricted to, security, smart cities, telemedicine, augmented reality, and others. Problem area number 3 involves 5G relays. Establishing sufficient 5G coverage area requires an investment in static tower infrastructure. For military applications, particularly in expeditionary environments, this investment is reflected in time, manpower resources, and incurred logistical support. For more temporary episodic networks and connections, the cost benefit of multiple static towers to further extend the 5G network can be unfavorable. Problem area number 3 seeks to dynamically extend the reach of 5G infrastructure through mobile 5G relay nodes. Solutions should have the potential to be integrated into legacy or future mobile platforms, such as ground vehicles and or unmanned aerial systems. Problem area number 4 acts as our catch-all. We certainly don't pretend to know all of the interesting and novel 5G use cases out there. And problem area number 4 acknowledges that, specifically calling out other 5G-enabled technology, solutions that support the modernization of energy management, perimeter security, identity management, personnel tracking, and other innovative use cases that will support Navy and Marine Corps operations. By design, problem area number 4 is open-ended. With the problem areas defined for you, I'll get into the judging criteria. In a few minutes, we'll introduce our 3 expert advisors who will be engaging with and asking questions directly to the 10 pitching companies. These experts will help both the audience and us as the government judges better understand each company's potential opportunity to solve one or more of our strategic problem areas. It's worth noting these advisors will not be making the final decision on the winners. The winners of today's pitch will be selected by a judging panel consisting of government personnel representing the Navy and Marine Corps. Myself, along with our other 2 judges, will be evaluating each company using the following 5 criteria. Number 1, technical, the soundness of the technology and the innovation of the proposed approach. Number 2, the team, the qualification of the company's principals, support staff, and consultants. Number 3, commercialization. Does the company have a technology solution that is viable in non-defense markets as well? This goes back to that dual use theme that was touched on earlier today. Number 4, reasonable or viable. Could the company's solution actually be tested and demonstrated within Marine Corps Air Station Miramar's 5G Living Lab within the given time frame? And lastly, number 5, the quality of the pitch. How well the company presented a clear and concise overview of their company and their technology, demonstrated how their technology is solving one or more of the defined problem areas, and responded effectively to questions from the strategic advisors. With that, good luck to all of you pitching today. And at the end of the day, our final speaker, Mr. Alex Phipps, the Deputy Chief Technology Officer at Navwar, will announce the winners. Back to you, Joey.
All right. Well, thank you very much, Tom. I appreciate it. So it is my pleasure to talk a little bit more about how the pitches will be conducted. Each team will have 5 minutes to pitch, and then they'll be asked questions in a Q&A session by our esteemed panel of advisors. I will cut you off. Please believe it. I will cut you off if you go beyond your time because we're running a tight schedule. So very excited to hear what everyone has to say. Also, we will make sure that I will introduce the companies, and then we'll have a little video play. And then from that point, when the video ends, that's when the 5 minutes start. So I'm very excited to conduct this and kind of help out with this event. With that, I'm happy to introduce our esteemed advisors. Because they are so esteemed, I'm actually going to read from their profiles, and I hope that this goes well. So firstly, we have Mike Jantz, who's the Senior Director with Qualcomm Ventures based in Silicon Valley. He primarily invests in mobile, AI, cloud, and automotive technologies. Throughout his career, Michael has focused on technology startups. He was previously a Managing Director at Samsung Ventures and an investor at Harrison Harris Group and Arch Venture Partners. He founded a semiconductor startup with a university researcher and founded a startup to create new engineering polymers. He also worked in the mobile semiconductor industry in M&A and corporate strategy at ARM, and in the semiconductor fabrication at Motorola. Michael has a BS in chemical engineering and an MBA from Chicago Booth. One good, we're good. All right, next up we have Jeff Black. Jeff is the Managing Director at Verizon Ventures. Jeff joined Verizon Ventures in 2012. Prior to Verizon Ventures, Jeff joined the Verizon in 2009 and was involved in numerous M&A and strategic investment transactions. Previously, he worked in investment banking at JP Morgan, structuring debt, equity, and M&A transactions. Prior to JP Morgan, he worked in the corporate finance department at Delta Airlines. Jeff received his BS in business administration from the University of North Carolina at Chapel Hill and an MBA from the Gozeta Business School at Emory University. Lastly but not least is Colonel Randy Pugh. He is from Annapolis, Maryland. He is a career intelligence officer who has served at 1st and 3rd Radio Battalion, the 31st Marine Expeditionary Unit, 1 and 2 Marine Expeditionary Force, and Special Operations Command Europe. He commanded the 2nd Radio Battalion and Marine Corps Intelligence Schools and served in combat in Iraq, Afghanistan, and the Philippines. He is a graduate of the U.S. Naval Academy, the Naval Postgraduate School, Marine Corps Command and Staff College, and the Naval War College. So thank you very much for you all joining. Right now, we will take a short pause to bring up our first company's deck, and we will be right back with you. All right, we're ready to go. Our first company is Tawbite.
Software carries a heavy load that represents more than 80% of the cost of building and running software infrastructure, managing OS containers at VM, and service scaffolding. At the end of the day, building and operating software applications today is complex, time-consuming, and expensive. This problem gets worse at the edge of the network. In 2019, we counted more than 26 billion active IoT devices, growing by over 100 every second. There has also been over 20,000 proximity data centers in the US alone. This is what's living at the edge of the internet. That will skyrocket with the rollouts of 5G. This is penalizing a segment. This is penalizing a market that the IoT segment of it will represent over 200 billion by 2025. So the question is, why can developers only focus on the functions and delivering the features that the use cases or the users need? So by eliminating, and that happens by eliminating software development, deployment, and networking complexity. So those developers can focus on the product features, and that will reduce cost, but also time to market. Stack abstractions happen starting from physical servers where software was deployed initially. With the available containers that went away, and we started automating deploying software on those containers and VMs. That was the rise of cloud computing. The next evolution that happens was serverless, where developers do not need to manage a VM, a containers, or whatever. They just focus on writing their functions. However, that even doing serverless, you still need to manage some operations on the networking side, on the devices side, manage different hardware types, and so on. We took that to the next level, where there is no human intervention on the operation as well. So combining serverless with the no-ops concept, we created the solution that permits software to scale to IoT and 5G. Hi, my name is Sami Fodil. I am the founder and CEO of Taubyte. At Taubyte, we created the first smart computing platform that enables scaling software to the global infrastructure, catalyzed by 5G and IoT. Smart computing is a distributed computing platform which streamlines running business logic on a global computing infrastructure that extends from data centers to connected devices. Our team has been featured recently in Dallas Innovates for joining the 5G Open Innovation Lab, founded by T-Mobile, Intel, and NASA, and winning the CW Technology and Innovation Award sponsored by Qualcomm. We have a couple pilots using our products. They're building IoT solution and connected devices based on our platform. We're working with different devices manufacturers to enable their products using our platform. So the question is, how do we do it? How do we go to platforms that need a lot of operation and developer to do a lot of scaffolding to get to run functions to something that does it for you? So first, our platform is fully serverless. We leverage a technology called WebAssembly that is highly secure, efficient, flexible, but also hardware independent. Same code runs on an Intel and it runs on an IoT device. That technology is called WebAssembly. We deploy our software in data centers. Our client deploy it on their IoT gateways and devices, building a peer-to-peer, resilient peer-to-peer network. We created the intelligence that dynamically provision proximity services when it's needed, where it's needed. Those are the services we offer: ledger, storage, database, message broker, function execution, all the services you need to build a modern IoT solution. Our business model is function as a service and software licenses subscription. Some attributes of our platform. So our platform natively deduplicate, authenticate, and self-certifies data. We also optimize telemetry, so only what change is transmitted over the air. Super important, our technology survives partitioning or disconnection, changing, going from network to network. That happens under the hood. The developer doesn't have to worry about that. We can also dynamically establish tunnels to IoT devices and execute functions, redirect ports, and so on. Our team has over half a century experience in cloud computing, edge computing, and IoT. We have two advisors, Mark Tilley and Scott Collison, with extensive executive experience. Mark Tilley is one of the top spokesmen for edge computing. Thank you.
Okay, well, thank you very much. And now we'll throw it over to our panel. I'll start with Mike.
Yeah, thank you very much, Sammy. I appreciate that that overview. Have you run into some limitations of WebAssembly versus container deployment? How would you compare those in terms of functionality?
Yes, that's a good question. So the reason I'll start with the reason why we went to WebAssembly. So at the edge, you need to quickly and efficiently provision those computing functions. Doing it with containers is kind of heavy. So you need to, you know how container, when you pull a container in Docker or Kubernetes or whatnot, it takes a couple minutes to do so. So where it is very easy to move a file around. So this is why we went WebAssembly. Those are very small files. Yes, for the limitation, we want, our plan is for stuff that cannot be compiled into your functions. Our plan is to build a marketplace where we provide some of those features. I'll give you an example. Let's say you need to do video processing. Instead of shipping FFmpeg in your container, you'll just leverage a library from a marketplace, and then run those functions.
Okay, that makes sense. Are your main competitors then? You know, you're kind of like a mix, but you see your main competitors being an AWS Lambda, or who are your main competitors?
Yeah, I would think that the main competitors are today's computing platforms that are like they're very suited for cloud computing, but it's very hard to move them to the edge, as they require a lot of ops to be done.
Great, thank you.
As you look to commercialize, are you targeting a certain kind of industry vertical, or are you agnostic completely to anyone using disparate sensors or solutions?
Yeah. So our technology is generic. It can be applied to different verticals. On the sales side, though, because we're a startup, we're focused on the IoT, and more specifically industrial IoT segment of the market right now.
For small devices or larger devices?
Yeah. So generally, I'll tell you about the use cases we have now, right? So the use cases we have as of today, all of them, and most of the industrial IoT use cases rely on some sort of an IoT gateway, and our software is deployed at nearby data centers, where if there is no gateway, those functions are still available nearby, and can be deployed on the IoT gateway itself, where the processing stays local. Generally, they save over-the-air communication as well. That's the main concern so far for our application that require having that IoT gateway doing all the processing and storing some of the data.
Got it. Thank you.
Hey, Sammy, Colonel Pugh here. Thanks for the brief. Appreciating the limitations of time that you can talk about technology or the military application use case, naval application. I'd be interested in hearing your thoughts on how this technology would be applied to the Navy or Marine Corps, whether that's in a bases and garrisons and stations environment, or whether that's in an expeditionary environment supporting naval operations in combat. Do you have any thoughts on that?
Yes. So the goal of our platform is really to simplify making software that scale on 5G networks. Software that can easily be deployed and updated, but also software that can be resilient in cases where it needs to work offline, in cases that it's jumping from one network to the other. And we handle all of that under the hood, where the developers only focus on writing those functions and that business logic. That can be applied to many use cases in the military, including like having our software being present on, for example, vehicles, and processing the data from the vehicle, for example, and so on. The other advantage that we offer is our software can come in a fashion where it is a private deployment as well. So it can be privately deployed, and that peer-to-peer network and all those functionalities can run on a private 5G network with no outside or communication to the outside world, or just like keeping everything happening on that private network.
So if I could, a follow-up. So do you see that this is something that Marines and sailors would be trained to use while deployed on a ship, or in an expeditionary environment, so they could be quickly developing applications for their edge devices as the conditions are changing, or as they learn new things and want new features? Or that it would be a callback to some help desk where those would be rapidly prototyped, tested, and then deployed out to the edge based on reports coming back from the front, kind of thing?
Yeah. So yeah, basically, like what you said is totally feasible. Like, as long as a developer has access to the source code of their code, and they can modify the code and push it, and then that will be deployed automatically to all the devices that are using that specific function at that time. Hopefully that answers the question. So rapid iteration is definitely one of the use cases.
Great, thanks, Sammy.
Yeah.
Okay, we are at about time. So thank you very much, Sammy, and we'll hold for a second. All right, and we're back. And next we have vRotors.
My company is vRotors. Our software platform provides real-time control of drones and ground-based cameras for distributed teams. This provides a common operating picture for those team members on base and out in the field. Let's look at a use case. There's a report of an intruder climbing a base fence, and security is sent out to investigate. Once on scene, they power on the drones, and at the command center, the operator presses the takeoff button to launch them into the air. The command center team views the scene annotated with AR markers showing suspect, ground unit, and other asset locations. That persistent global AR enables coordination with ground units who have a view from their own location perspective. The distributed team collaboration architecture provides different permissions, including remote piloting, controlling cameras, and monitoring video and data streams by any team member. In the Ops Center, our platform provides overall management of cameras and drones. The view is also available in 3D terrain perspective to bring out vertical separation distances. vRotors is available across PC, Mac, mobile phone, AR and VR headsets, and even web browsers. The platform consists of the user applications that we just mentioned, applications for the connected devices, and an intelligent edge service to which everything is connected. Some key technology innovations include the world-scale AR, the complex management of matching users and devices, real-time data distribution and processing, including machine vision and smart vehicle navigation, and an API providing open integration to other devices. Our platform is live and operational with integrations to drones and cameras. This is the PC application screenshot of remote drone piloting with AR markers in the scene. From the ground at the same location, this is the 360 camera view from which ground controllers can control the camera in any direction. The same AR scene markers are visible along with an AR label from that live drone. This is the mixed reality mobile camera view for the ground units on scene. They can also switch into a virtual cockpit mode to pilot drones. We have a number of live commercial applications. Over the past year, we've hosted hundreds of live drone races with Twitch video gamers and their audiences. Our best pilot is in London, remotely racing a 4G connected drone in Southern California. It's really driven to us to perfect our platform for low latency responsiveness and robustness. Here's a pair of remote pilots in a virtual 3D cockpit, VR racing a real drone on our AR-defined course. We also have enterprise projects with some amazing partners. First, we're working with Dish Network to help them with remote tower inspection using real-time remote drone pilots. We're also working with Maxar on 3D map applications to provide synthetic visualization during bad visibility and low bandwidth conditions. We're working with Honeywell on remote supervision of autonomous air taxi fleets using our multi-vehicle flight management technology. We're also working with IAI to automate the landing process for their next moon mission using our machine vision and auto vehicle navigation capabilities. We are team members with Duke University and the University of Illinois in the ANA Avatar X Prize Robotics Competition. As a team, we have innovated deep space trajectories at NASA JPL, small launch vehicles at Orbital, and pioneered mixed reality at Niantic, creator of Pokemon Go. We have 5 full-time team members supporting product and business development. Our strategy is guided by an elite mentor group from the Air Force, Navy, Virgin Orbit, and NASA JPL. Our innovation has been recognized with selections in the Techstars and Aero Innovate incubators, AFWorks challenges, and attention in the press. If we're selected in this competition, we can deploy our functionality for an immediate technology demonstration utilizing our existing company camera and drone assets, followed by a phase 2 involving a carefully planned integration to base assets. At V-Rotors, we're enabling the live connection between Marines and seamen to 5G remotely connected drones and ground cameras for a real-time view of base operations. Thank you, and I'd love to take any questions.
Okay, thank you very much, Neil. We're going to pass it off to our team of advisors.
Yeah, Neil, your platform, could it be used by startups that are focused specifically, for example, on cell tower inspection, or would they be competitors?
Absolutely could be used by startups in cell tower inspections or any of the applications that I described. So our long-term goal is to be an underlying platform supporting hardware innovators, service innovators, to run their services on our platform. And just to add, it is quite an effort to maintain these applications across the broad breadth of platforms, AR, VR, mobile, and PC. It's that's really our job to allow these innovators to deploy their services.
And the key technologies you provide, there's, I'm guessing it's mostly around connection management, and then maybe video processing. Is that? Could you sort of summarize what are the key pieces that you provide?
Absolutely, and if I give an analogy, which somewhat of an analogy, was like if you want to make a rocket and it launches into space and it works, it's very, there's a lot of complex sort of subtleties to make a system like this work, where you have somebody in London racing a drone real time in Southern California. But it includes certainly a robustness in being able to manage user sessions with the vehicle. If they disconnect, the ability to reconnect with that real-time video and still be aligned with the telemetry and still have control of the vehicle. The world scale AR, so visualization, user experience is absolutely key to any of these kinds of remote vehicle controls. And so we've iterated there, and we're coming out of the video game industry where we have some strengths in providing that. And then underlying the ability to, video stream data and telemetry data, they don't come in at the same rate. Plus we have avatar, voice data, UDP, TCP, and getting all of these things aligned underneath is actually quite a trick, so that from a user point of view, everything is aligned and works. And then finally, the ability I described to you for IAI, what we're doing for automated moon landing, machine vision and all, the ability to add in that real-time autonomy in that cloud connection, if you will. And so we would really look forward to test that kind of improved latency at the Miramar site. But that's where a lot of our additional features are being added.
Great, thank you.
Thank you, sir.
Question about the remote piloting. So absent kind of a beyond visual line of sight waiver from a commercial perspective, how are you achieving, you have visual aids or people on site, or how does that work?
Yeah, yes, sir. In today's regulatory environment, it does involve visual observers. That's correct, to be within the existing framework without a waiver. And so there are really two cases. So one case is you have the uncertified pilot over in London, and we have a certified pilot in the field. And the second case is where you may have a technician at a cell tower who's not certified, but the certified pilot is at the headquarters actually piloting the vehicle. So as long as there's a certified individual at either end, then we're fine, and that's how we work it today. And I'd just like to add, though, we are looking forward to beyond visual line of sight kinds of operations, and what I alluded to with the Maxar work we do with the digital twin, the ability to navigate with, for example, over low bandwidth satellite connections is sort of our foray into that kind of technology to enable that.
Gotcha. Thank you. And then as far as hardware, do you have specific kinds of equipment that you work with, or are you completely agnostic?
Yeah, that's a great question. So we have hyper-focused on the software solution, ranging from your VR headset and your PC and your Mac down to software that connects to the actual devices. And but we are not a hardware innovator, so we really are a platform to integrate with any hardware innovator who's looking to partner with us, and we're open in that way.
Okay, great, thank you.
Hey Neil, thanks for the brief. Colonel Pugh here. I was just going to ask about the disconnected and specifically in a contested electromagnetic spectrum environment, where it's not just network congestion that's causing unpredictability in your connectivity, but it's being intentionally done. You started to get after it, I think, with the comment about the satellite communications. What are your thoughts on being disconnected from the network and then reconnecting to the network? What happens in between with your system?
Yes, sir. That's a great question, and we face this in two of our scenarios today. So one is by a cell tower, there's a lot of interference. The second is in some of the ideating we're doing with Honeywell on the beyond visual line of sight as we go beyond LTE coverage. And so there is certainly a hybrid approach between the autonomy on the device that is required. And so what is the behavior of the vehicle if there's a broken communication link? So in a case of a quadcopter, often you can just either auto navigate to a safe point where you think that there'll be coverage, or where you think you can land safely, or you proceed to the next safe point. If it's a winged vehicle, the risks are a little bit higher, and that needs to be thought through as far as what does the vehicle do. But this is certainly one of the fascinating challenges of this whole problem. How much intelligence do we put on the vehicle versus the edge versus the cloud? And we're excited to be working through that in practical use cases.
Thanks very much for your answer, Neil.
Thank you, sir.
Okay, if we don't have any more, we're about at time. So thank you very much, Neil and vRotors.
Yeah. Thank you, everybody. Thanks for the opportunity.
All right, next up we have Athena Tech.
Good afternoon. My name is Janio Sanchez. I'm the president of Athena Tech. Our 5G instrumental player unit is a smart device that can communicate 5G, 4G, and Iridium at the same time. Our connectivity also includes two wireless and wired sensor systems. Our 5G IPU is built on a proven architecture, having this device being fielded at 14,000 devices at the National Training Center and JRTC as well. Our 5G IPU also has commercial applications and use cases that you'll see how it meets them. Athena Technologies is a network-focused, solution-driven small business based out of Orlando, Florida, as you've seen on the short video. As direct past performance to these use cases is that we built LTE Cat M1 devices for drone tracking, as well as we built a multispectral kill indicator for operational testing for the Apache test event at the Marine base. We have demonstrated our capabilities, and we've been trusted by the top 5 U.S. defense contractors. This is our player unit device. This is our baseline product. It was built by Seco, our teaming partner. Like I said, it's been fielded over the last 5 years. It's been proven to be operational. Our other teaming partner is Sierra Wireless. We have signed an agreement for the Qualcomm NDA to provide millimeter wave solutions to the government. This device also has FIPS 140-2 encryption. The architecture, importantly, we've tested and fast prototyped the architecture to be able to also work on Iridium. And that's the critical part of our solution, that will be able to run from 5G to Iridium and back to 5G. And that will help us solve the autonomous vehicle use case. These are 5G player unit as designed. This would be available in the January 2021 timeframe. That will be operational using sub-6 gigahertz. The millimeter wave will follow soon after that. It depends on product availability, but it's currently designed and is being built as part of the 5G ecosystem with Sierra Wireless. So our device supports the augmented reality, virtual reality using USB. It reports data collection. It also does all the miles engagement that's currently used by the Marine Corps for the force-on-force next generation system, for example. And we're also able to do all these other use cases, autonomous vehicles and sensor systems. So in the case of the autonomous vehicles, we will be implementing software that would allow us to the 5G IPU to become a smart edge device, providing the signal quality information from the cell edge. And that will tell us when we should be able to roam into Iridium, and while we keep track of the RF environment and be able to go back to 5G. That's the key component of this. You'll see that our architecture actually leverages 2 different transceivers in the architecture. So you'll be able to do 5G and Iridium at the same time. Other sensors, because we actually work on multiple of the use cases that you have. All the sensors that we can support are part of the forward operating bases. These sensors are part of WISeSat's missile range that are used for missile testing. In terms of commercial solutions, we feel that all the DoD work that we've been pursuing will have a direct implication into these 5 commercial use cases for mining, container ports, transportation, transit, and industrial robots. All of these require sensor systems, as well as they will require networks, including MANET protocols in terms of the mining, for example. The way we determine how to solve the use cases is by applying a holistic systems engineering approach that includes modeling and simulation. Our modeling and simulation, for example, WISeSat demonstrates the different test ranges and capability and throughput of each of the networks. Of course, these solutions are not require significant software development. You don't only have a smart RF device, you also have to have smart software, and that's what we will be working on. Thanks so much, and I'll take any questions.
Okay, thank you very much for that, Athena Tech. We'll pass it over to our esteemed panel.
Hi, Janio, thank you so much for presenting. What is the cost of the IPU for commercial applications?
The existing IPU, it runs at about $1,200 without the battery, right? It's designed to be used with the LineWire battery. The LineWire battery, you have 100,000 of them at the different ranges. So it's designed to be built to run in 96 hours, for example.
Okay. And do you presently, the frequencies that you support, are they military frequencies, or for example, the Iridium satellite, are they commercial as well, or just easy enough to change to commercial?
That's a great question. So this device is actually supports commercial cellular frequencies. The next generation device that we're building, the 5G device, will support the shared spectrum on CBRS. It will go all the way to the 38 gigahertz. And what I was trying to show in the modeling and simulation is that the 38 gigahertz that belongs to the government, that can be used by the government, can also take you out of the commercial space, right? So you can either go with 28 gigahertz on the millimeter wave, or you can go to 38 gigahertz on the DoD spectrum that it uses. But it's strictly, it doesn't work on 225 to 400, for example, right? But it does work on CBRS spectrum, that is a shared spectrum. It'll also work on the 39 that belongs to the DoD. That's how it's designed to work on. This is a strictly commercial cellular.
Okay. And is your, one of your main advantages now in this model that you're field tested, you've got 14,000 in the field. Is that sort of the at this point your primary advantage?
My primary advantage is understanding how to build these devices for those harsh environments, right? These have been field tested at the NTC and at JRTC, and the architecture is also a prime advantage. Where the architecture, we were able to change the transceiver chip on it. We were able to put Iridium, we were able to put Cat M1, right? So with Cat M1, you go from $20 a month that you currently pay at the NTC to $3 a month, right? So it depends on the throughput that you require. If you're just doing TCP, RTCA data, right, small amount of data on this network, there is no need to pay a $20 a month bill, right? You can do it for $3 a month as an IoT device. And that's what we're proposing. That's a viable disk we can bring to Miramar. You can test this device, you can test the Cat M1, you can test the Iridium version. That's kind of our approach. Crawl, walk, run, where we show this device has a single transceiver chip. The next generation has a dual transceiver chip where you can plug in Cat M1 or you can plug Iridium as part of the same architecture. So all the lessons learned from having fielded and the improvements that we bring, for example, FIPS 140-2 may be expensive on a license basis. So we are putting an AES-256 chip built into the device as well.
Good, thank you.
Thank you for that. As you go to market in the commercial sector, mining is the one that I remember that comes to mind. What's the go-to-market strategy? Is it with the end user, the hardware manufacturer, some fleet management type company that handles the autonomous, or how do you envision kind of going to market?
The going to market to the mining sector, the requirement there is to build the MANET extensions on top of the player unit, right? So you want to be able to build an ad hoc network that would have the peer-to-peer connection to it, right? So once we develop that capability, then the go-to-market will be to create a product for specific use cases. So we will use our 5G IPU to determine what the specific use case is. Mm-hmm. We currently have, for example, Zigbee built in. This device supports Zigbee as is with LTE. It supports Bluetooth LE. The next generation device will have Wi-Fi as well. So we'll be able to determine what the right use case, what the right mix is, and then we'll be able to lower the cost of the device and lower the complications of all the RF, all the transceivers that are built into the 5G IPU. In terms of commercializing the device, to be honest with you, we're being so focused, we're a small business, we're so focused on getting the architecture done correctly, the engineering done correctly, that we see that there are a lot of different steps before we get to that point, but it's something that we will certainly need to address in the short term, perhaps with a little funding from the right folks.
Gotcha. And I think you touched on it, but so the idea is that right now you're building kind of the top of the line model that can do everything, and it's very hardened. But some use cases might not warrant such a robust device with connectivity and or kind of the ability to work in harsh environments.
So we'll use a systems engineering approach, and we'll look at the requirements, right? And then those requirements will dictate, for example, for force on force next. The key thing for a warfighter is to have a very small swap, right? So the smaller the device, the lighter the device, the better, right? So then we will strip out all the other components that are not necessary, right? So some devices, for example, the Zigbee, used to do V-test as part of the training events, and that system is only going to go to Germany at the moment, right? So the Zigbee chip can be pulled out, it can be less expensive, it can be lighter. The design itself becomes less complex because of the number of antennas that you're going to support. If you're going to have, we're doing some work for missile testing at Weissman's missile range. They actually want to have higher throughput. They require 128 megabits of data coming out of these HD cameras that are built as part of the operational test, right? So for that, then we're more focused on the massive MIMO aspect of it, and the beamforming aspect of it. So that's okay. The approach is this becomes a test bed for you to test your technology and the use cases and determine what the requirements could be for the DoD on the commercial side as well.
Excellent, thank you.
Joey, do we have time, or are we out of time?
Oh, keep going, you have time.
Yeah, sir, thanks for presentation. Just one question. If you could, because I know your brief had to cover technical and the use case, but just focusing on the Marine Corps use case, either support the bases or stations, whether that's logistics or force protection, or in an expeditionary environment. Can you give me like a 30-second compelling use case for your system and how it provides advantage to the Marine Corps?
So the advantage would be to have a 5G player unit or 4G, right? Depends on how much data you're transmitting, and the ability to put a MANET protocol that would allow me to talk to you directly without having to go to a tower, right? So the ability to multi-hop across the range to bring back the traffic to the G-Node B, or you can take it back to a drone that's holding a G-Node B as well, right? Or smart relay system. That's how, and you can shape the network by designing the right massive MIMO system. If you're doing high power millimeter wave, for example, what kind of systems can you put on the vehicles?
All right, thank you very much.
Thanks for your time, I appreciate it.
Okay, next up we have OmniSpace.
Good afternoon. OmniSpace is creating a hybrid pole-to-pole 5G communication system that will enable seamless transitions between urban, rural, and maritime domains, overcoming the need for multiple devices on multiple networks. We do this by fusing the reach of satellite with the power of cellular to harness our unique 2 gigahertz spectrum, bringing interoperable one network connectivity to users and IoT devices anywhere on the globe. We're partnered on the NSIN Starts project with LinkWest, an industry leader in innovative space platforms and communications. OmniSpace was founded by the same investors and technologists who created SiriusXM radio. What a lot of people don't realize about SiriusXM is that in a city, you're listening to the signal off the cellular network, and then when you leave the city, you switch seamlessly over to satellite. OmniSpace is harnessing that same technology for global voice and data. We create partnerships with mobile network operators, whereby they have access to our S-band spectrum to improve the quality of service to their existing users. In return, we're able to create seamless connectivity for mobile and IoT devices as they leave the cities and venture to rural and maritime domains, all in the same spectrum. We effectively become the non-cellular roaming partner for anyone or anything leaving the cities in a 5G world. OmniSpace owns and operates an extensive legacy capital investment infrastructure in space and on the ground. Here you see the actual footprint of our F2 satellite operating in MEO orbit at 10,600 kilometers. We also leverage a worldwide ground station network that runs the TT&C for F2 in the C-band. F2 also plays a key role in a number of commercial and military pilots around the world. We're currently preparing to pilot a commercial drone solution together with mobile network operator TELUS in Canada to maintain connectivity to UAVs, surveying gas pipelines and other natural resource endeavors when they venture in and out of cellular coverage. In Brazil, Fogás, a natural gas company, is using our terminal to track its barges along 1,600 kilometers of the Amazon River as they go between cities and rural jungle. And as many of you know, our Marines in the high north have been high comms challenged and are seeking new solutions. Over the course of 3 trips north of the Arctic Circle at 70 degrees north latitude, we've used our legacy satellite and a simple prototype terminal to connect the Marines to live WhatsApp video, and later on the move, in a snowstorm, using an omnidirectional antenna, we successfully had the mobile command post you see here connected to NIPRNet. Our globally harmonized 60 megahertz of 2 gigahertz S-band spectrum creates spectrum diversity and increased capacity. We have 6 times the capacity of the only incumbent pole-to-pole mobile satellite services provider, allowing us to unlock and unleash the potential of 5G, not only in cities and on base, but when people and devices venture beyond. We're excited to be working with the top US OEM satellite manufacturer on our next generation NGSO constellation, which we expect to launch in phases to de-risk technology and perfect both waveforms and UEs. At risk of biting off more than we can chew, we actually believe OmniSpace has the ability to address all 4 of the problem sets. When we read number 1, we thought this is precisely what OmniSpace is built to do. For problem set 2, we believe that the unique characteristics of our S-band system particularly enables very small mobile devices with omnidirectional antennas. Regarding the desire for ad hoc agile networks, OmniSpace's 60 megahertz of globally harmonized spectrum provides the opportunity for the Navy and Marines to access and harness our capacity on instant terrestrial networks backed up by the coverage of our satellite. Finally, in line with OmniSpace's current Space Pitch Day SBIR contract, we believe that we are already on the path to providing global, resilient enterprise voice and data within the fighting SATCOM vision, which we believe fits within problem set 4. Hopefully, the various demos I described ignited your imagination for the myriad applications of our system. The possibilities for our solution are endless and will be leveraged by commercial enterprise users across industrial IoT verticals. Because we're effectively an MSS, IoT, and personal communication service company, we're eager to tap each of these markets concurrently. We believe, like everyone participating in this event, that these markets will experience explosive growth in the coming decade, and we're positioning ourselves to fill connectivity gaps that other 5G stakeholders are overlooking. We're privileged to have part of our team 3 senior former government leaders. OmniSpace executive team has a breadth and depth of experience that we're confident will continue to succeed in creating value. We have leaders from all industries and government, but particularly from the telecoms and aerospace fields. Our and LinkWest engineers and executives have a track record of bringing successful innovations to these areas. OmniSpace and LinkWest are truly honored by the opportunity to present here today, and we are thrilled to partner with the Navy, Marines, and Verizon. Thank you, and we look forward to answering your questions.
Okay, thank you very much. Thank you very much, Campbell. And so now we'll turn it over to our esteemed panel of advisors.
Hey, Mike, can I go first? We keep making you go first, sorry. Hey, Campbell, thanks very much for the brief and cool technology. The question that I have regards quality of service. So certainly, streaming music or getting on NIPRNet and having to wait longer for, your download when you're on the SATCOM than when you are on the 5G network is acceptable in some cases, but not acceptable when it's C2 fires, ISR, or targeting data. So do you have an intelligent way of handling the shift back and forth between the different bandwidth and throughput that you would get or latency issues that you would have shifting back and forth?
That's a great question, sir. Let me try to answer it in 2 little pieces. So the first one is, we actually believe that the latency and lag on our next generation system that we're working on is going to be pretty significantly attractive, the types of speeds you would get from either LEO or a MEO constellation. call it sub 500 milliseconds. But nevertheless, and so we're trying to keep those times as short as possible. But nevertheless, to answer your question more directly, we're in the midst of building out kind of the core infrastructure in terms of how our satellite core links into whether it's a commercial mobile network operator core or a private government core. And figuring out how those trade-offs work are going to be part of the very important work that we look forward to doing in terms of making sure that those handoffs happen seamlessly. And that's some of the piloting that we're already working on today.
Thanks, Campbell.
Yeah. Campbell, I just want to ask, will your commercial beachhead be? What do you see as your first, application or market segment that you'll pursue heavily?
Another great question. We are currently licensed in some way, shape, or form to cover over 600 million people around the world in various markets. And we are really focused on various IoT applications specifically right now. We know that our spectrum lends itself to certain things. We're not trying to pursue the super high bandwidth, high speed connectivity, but rather focused on smaller bandwidth, absolutely critical communications in any environment, by the way, with small devices and omnidirectional antennas. So I think right off the bat, we're very much focused on the growing small off the grid or items that are both off the grid and on the grid but have that seamless connectivity. So focusing on providing commercial off the shelf types of connectivity. And by the way, this is all we're very focused on the 3GPP, especially the 5G kind of working group, to make sure that our frequencies and our technology are already built into the pipeline of chipsets that are coming down the pike. And so, I could name a couple different specific application use cases, and we have a sense that it's going to be IoT focused. We are looking at things like secret sauce, but looking at call it global handset provider types about giving critical connectivity. But we're really truly focused on making sure that the chipset is sort of ubiquitously available and that commercial users can buy any device, whether it's a tracking device for Maersk shipping containers to a personal communications device.
Okay, thank you.
Just to touch on that a little further, I get the shipping container, so I'm trying to figure out the cost. Do you see it being more high value IoT devices like a Maersk shipping container or something larger, or is it more the trillions of devices, the sensors that just need to kind of ping the network periodically, but they could be in a remote, or is it both? I don't know what the cost of transmission is.
Yeah, that's a great question. And that, I think, to be frank, is part of the business case analysis that we're probably currently engaged in. But I think, we believe that we have sufficient spectrum relative to some of the other players that are out there now doing similar type things that will have the ability to parse that market. And I think in some cases it would be, the billions or hundreds of billions of devices, down the road using very small drip to larger kind of mid bandwidth use cases. But as I said, as I said in the pitch, we're focused on, we know what we're not good at. There are lots of players out there that are trying to put up, thousands of satellites and feed you really fat pipes, but that requires a significant swap on the ground and in space. And we're focused on the smaller devices. So from the ones of kilobits to the single digit megabit speeds, whatever application use cases we can fit in there, that's what we're focused on.
Perfect. Thank you.
Okay. Well, thank you very much, and we appreciate your time.
Thank you for the opportunity. We appreciate it.
Okay, next up we have Arna Networks.
Good afternoon. We are an open source software company approaching 5G and edge computing from a management point of view, focusing on B2B use cases. Specifically, our software performs orchestration, lifecycle management, and closed loop automation of 5G network services and edge computing applications. Our software is applicable to all 4 NSIN problems, but as you can imagine, it's most applicable to problem 3, 5G relay. If you are rolling out dynamic 5G networks, the last thing you want is manual steps. That's simply not going to be viable. As I just mentioned, management is critical for software-driven 5G network services and edge computing applications. And the specific problem is that the stress on application management explodes by about 1 million times with 5G and edge computing. If you look at a cloud, you have a few number of sites, few number of application instances, but a lot of change. And enterprise looks almost exactly the opposite. 4G and LTE is similar to the enterprise, but fewer application instances. With 5G and edge computing, everything changes. You have hundreds of thousands of edge sites. You have thousands of applications, which when combined with network slicing, become tens of thousands. And the edge is a very dynamic environment. It's a constrained environment. You're not going to park applications. Applications will be coming in and out, network slicing, reconfiguration, migration, replication. So the net is, the problem is about 1 million-fold worse, and existing mechanisms of managing applications are simply not going to work. Our solution is our product, Arna Networks Multi-Cluster Orchestration Platform, AMCOP. AMCOP can be viewed in 3 layers. The middle layer is 100% open source, and the middle layer performs the 3 functions I mentioned: intent-based orchestration, lifecycle management, analytics, and real-time policy-driven closed-loop automation. This software is something we take from communities such as Linux Foundation Networking. Specifically, there is a project called ONAP, Open Network Automation Platform. We leverage that, and there is active contribution from not just us, but also Intel, AT&T, Bell Canada, Orange, and many others. We also leverage CNCF projects. On top, we have a proprietary value-add comprehensive 5G support set of software projects, and those include a network slicing manager, self-optimizing network, and analytics applications that include the non-real-time RIC for ORAN and the NWDAF or network data analytics function for the core. And at the bottom, we have an installer just to install and manage our own software. The light blue colors are what is available in our 1.0 product, and the dark blue represent roadmap items. This slide shows the product value. Our product, AMCOP, is a centralized application. Step 0 is we register edge clouds with our product, and they don't have to be edge clouds. They can be core clouds, public clouds. We register them. After that is done, we onboard applications, and these applications can include arbitrary cloud-native applications like drone control, AR, VR, ad insertion, etc. They can be analytics applications that include edge, AI, ML, CNFs, or cloud-native network functions, 5G RAN, 5G core, and firewall, etc., and platform services such as database as a service, etc. Then they're orchestrated based on intent, day 0 configuration, ongoing day 1, day 2 configuration, lifecycle management. We monitor these applications, and based on the telemetry, we perform real-time policy-driven closed-loop automation. The team consists of 2 co-founders, me and Sriram Rupanagunta. We are second-time entrepreneurs. The previous company, Arohi Communications, was in 10 gig Ethernet, also networking, sold to Emulex in 2006. We're affiliated with a bunch of organizations, including the 5G Open Innovation Lab in Seattle, Platform for Advanced Wireless Research, NSC. We're 15 full-time employees, and we have 2 active POCs going on at this time. And that concludes my presentation, and happy to take some questions.
Thank you very much. Thank you very much. We appreciate it. We'll pass it over to our esteemed advisors.
Okay, I'll go first. Mark, thanks very much for your brief and your presentation. The question I have is really about the military use cases for this. It's a question of the battlefield Internet of Things, where both the edge is changing and the infrastructure is changing simultaneously, either through contested electromagnetic spectrum or through physical destruction or something like that. You know, things being taken out of the network. And so, is this an appropriate solution for both like bases and stations, or is this also appropriate for like expeditionary environments, you know, on the forward edge in both senses of the term?
So we break down, so orchestration is an overused term. We break it down into infra, resource, and application. So we deal essentially with the application layer. So the infra would be dealing with, you know, failed nodes or adding nodes and bringing up cloud software on them, et cetera. We don't do that. Resource orchestration we leave to Kubernetes. And then we deal with the application layer. So 5G network services. So if there are more RAN sites that need to be added, we can handle that. If some go away for some reason and you have to migrate traffic, if core needs more capacity, if new edge computing applications need to be onboarded or moved around, migrated. So we can deal with a changing environment from an application and a network service point of view, but we'll rely on a different entity for managing the infrastructure. Did that answer the question?
Yes, sir. I think it did. Thank you.
Amar, thanks for presenting. And one question, just to understand business model, do you have both open core and proprietary software, or are you pursuing a pure open core business model? And if so, can you describe that a little bit?
So it's an open core only business model. So the middle layer is 100% open source. So there is nothing proprietary, and it comes from LFN and CNCF communities. The layer on top is proprietary. So the layer on top for network slicing, non-real-time break, NWDAF, SON is proprietary.
Thanks, that makes sense.
As you commercialize, kind of how do you, what's your first step to go to market and kind of the area that you will focus on primarily?
We see, it's just our point of view, we see 5G preceding these cool edge applications. As cool as they are, I think you need connectivity first. So the way we are progressing on the go-to-market is orchestration, management, and automation of the 5G RAN and the 5G core is sort of what we want to enable first. And once that is done, we start pulling in all these edge applications. So we are in 2 POCs, both are in open communities. One is cloud native 5G demo in the OPNFV Linux Foundation community. And one is a private LTE and 5G over CBRS, a demo in the Akraino, Linux Foundation Edge Akraino community. Hopefully that answered the question.
Yep, perfect. Thank you.
Is there another question out there? I saw somebody reach for maybe the mute, the mute or unmute button. Feel free. Okay. All right. Well, thank you very much. We appreciate your time and your presentation, and thank you for the Q&A from our panelists.
Thank you for the opportunity. Bye-bye.
Next up, we have Gen XCOM.
All right. Hello, everybody. My name is Sriram Vishwanath. I know that's a mouthful. Sri Ram, you can call me Sri Ram, and I'm with Gen XCOM. Not all of us are Gen Xers. We are Generation X Communications, shortened to Gen XCOM. And what we do, in a nutshell, is we enable 5G relays and mesh networks in a way not thought possible before. So we're excited to be here. It's a privilege to be presenting to this august audience. And I'll talk about what we do, how we solve it, and why we make a big difference in enabling 5G all around the US, all around the globe. Essentially what we do is we enable interference cancellation, and through that, we enable 5G relays. From a coverage, capacity, range extension perspective, relays make a huge difference in how you cover everything from spots where there's no coverage to extend coverage in the case of poor penetration, and in the case of millimeter wave and sub-6 radios. We go well beyond just doing relays. We do mesh networks. So we are able to add a lot of intelligence into these relays to be able to enable much greater coverage capacity overall, much better densification and scalability in our networks. All right. So what do? We enable relays through interference cancellation. And what is interference cancellation? When a transmit and receive coexist, they interfere with each other. It's like when I'm talking and you talk at the same time, we interfere. We make that interference go away. Essentially, we enable a transmit and receive that are co-located to coexist with no interference. And the way we do it is super unique, super unique. We do it using RF photonics. This is a really cool way by which you use photonics to cancel the interference in RF. So your radio is operating in the usual bands you operate in: CBRS, proprietary bands, unlicensed, lightly licensed bands, millimeter wave, you pick. We take the signal, convert it to photonics, cancel out the interference, and convert it back. And it's all RF in, RF out, but you use photonics to cancel the interference. This enables a very wideband, very frequency flexible radio, one that can operate in your band of choice and can enable solutions to transmit and receive bidirectionally at the same time, not just in one radio, point to point, but in a mesh fashion, where radios are talking to one another back to back, multi-hop, and are able to connect different parts from the tower all the way to handsets, different devices through a multi-hop mesh network. This gives us very wideband RF capabilities. So we're talking gigahertz bands here. We're talking highly flexible radios, high rejection, interference rejection radios, ultimately in very small form factors using our silicon-based waveguide technology. Ultimately, we're working not just in the telco space, we're working also in the private enterprise space, particularly what we call private 4G, 5G, both in CBRS and other private LTE 5G bands. And with our technology, we're able to improve penetration through walls, in factories, in challenging environments, in rural environments, wherever there is either a need for densification and improved coverage and capacity, or there is none at all, and we can enable it using our interference cancellation mesh architectures. One of the big advantages of this is that you don't need extensive fiber deployments. So you can take a space where there's little infrastructure and bring in the capability to do provide coverage and capacity, all at ultra reliable, low latency, what's called URLLC communication. So who are we? We are backed by Intel Capital, Asia Capital, BMW, iVentures, a whole slew of other investors, including Bandgap Ventures, FAM Capital, Capital Factory. We're about a little over 40, about 45 to 50 employees now, and growing in Austin and Phoenix. We founded it about 4 years ago. And we have a deep technical talent. We have about 25% PhD holders at the company with strong backgrounds, not just in telco, but in enabling applications for both consumer and enterprise end users. We have multiple federal and commercial engagements, and we're looking at a massive market. We're talking about the SOM alone being tens of billions, the overall TAM being much, much, much greater than that.
Okay, we are at time.
All right. Well, I'm happy to share more about GenXCom further as well. Thank you for your time.
Absolutely. Thank you very much. We'll pass it over to our esteemed advisors.
You touched a little bit on kind of your go-to-market, but just given your investor base and some of the use cases that I just envisioned that they would use, do you see going through the enterprise side first or more on the telecom hardware provider infrastructure play?
What we found is it's a very interesting push-pull between the two. There is a natural, the enterprise is an underserved market, not just generally directly to enterprise, but even through the telcos, and the telcos very much recognize that as a huge opportunity for themselves and for the whole connectivity landscape. And so we see this as a unique push-pull opportunity where we're able to partner with telcos to make a big difference for enterprise customers. And so there is a not just a natural alignment and partnership, but there's a sales model that enables us to work with the telcos to improve their top line, bottom line, while addressing the needs of the enterprise.
Sure, Colonel Pugh here. Can you talk a little bit about the privacy and security, desirable features of 5G network for the military as well as for commercial applications? The privacy and security, preserving that from the extension point to the handset or the edge device, and then all the way back to the network.
Yep. In fact, I had a slide on that, but I can speak much more to that. So one of the biggest aspects of what we do is secure private mesh LTE 5G networks. The here are one of the biggest benefits, not just from the end-to-end encryption pieces, but also the authentication, the overall device management features, and the ability to be able to track individual accesses to a much more fine-grained level. So you can do a much greater, much more fine-grained detection of exactly who is doing what within the network. This reduces the attack surface by something like 1000x. It's pretty crazy compared to conventional networks. But the advantage of security and the privacy that comes with it in terms of what we call CUPs, or control and user plane separation architectures in private networks, gives you a great degree of control over who accesses which piece of data and how that access pattern is controlled. So you can do very fine-grained access control together with much greater overall security using our architectures.
Thank you.
A pleasure. Thank you for these questions. These are great questions.
Shriram, just for the interference cancellation, can you talk about the cost of your solution on each side of the RF link? And then is just for the interference cancellation, is this just a hardware solution, or do you need software running on a host processor as well?
It is a hardware solution with firmware to be able to control and manage it. And I'm going in the reverse order to answer your question. Yes, you would have embedded software that goes with it. The embedded software is actually the easiest piece because it would go into the existing application processor. The hardware piece itself is a combination of silicon with additional RF components and scales extremely well as it is silicon. So if it were a complicated non-silicon structure, its scaling behavior would be much harder. But here, as the volume increases, the costs steadily go down. So one of the aspects of us working on this with you would be to be able to scale this to a point where the resulting costs of the silicon become trivial compared to the rest of the infrastructure. The beauty of it is because it's a silicon-based canceller and it's in the shunt path, that means it doesn't go on the transmit or receive, it goes between. It doesn't mess with your transmit, doesn't mess with your receive, it's waveform agnostic, it is protocol agnostic, and all it does is sit in the middle and give you this cancellation behavior that's tunable and wideband.
Great, thank you very much.
My pleasure.
Yeah, Colonel Pugh again. I think you just answered my question, but no additional modifications or costs for the edge devices.
None at all. In fact, you could do just on one side if you wanted to. The cancellation doesn't have to happen everywhere to get the benefit. The beauty of inference cancellation, even if you did it on one device once, you start seeing the benefits right away.
Thanks.
any interference I can get rid of, I'm very happy to work with you to make sure it disappears.
Yeah, assuming that means intentional interference as well as unintentional interference, co-site interference type stuff.
Yes. So co-site any co-located interference. It could be two different waveforms. You could be talking about radar and something else. You could be talking about two different protocols.
Adversary jamming.
Adversarial jamming, intentional, unintentional jamming, deliberate jamming to protect your own communications. All of these configurations are not just good use cases, but many use cases of RF photonics is the best way to solve them.
Okay, any last questions? Okay, all right. Well, thank you very much for your time, and we appreciate you.
Thank you for taking the time.
Okay, next up we have IoT AI.
Hi, I'm JD Stanley, the CEO of IoT AI. Thank you so much, NSIN, Navex, Navy Marine, Verizon, Qualcomm. I'm just honored to be able to give you the presentation. We want you to walk away with a couple things. When it comes to 5G, we are perfectly ideally positioned to help you do transition testing to figure out what works, what doesn't work, in mission side, non-mission side. Additionally, we have a lot of backing, and OS&D has actually already invested us in what we're going to show you. And so there's actually some really good synergies about going forward. As part of that, I want to give you what we are. So there's a lot of buzzwords. I have a buzzy name as a company. I'm an ex-Cisco exec, so I all know a lot of this language and network stuff. And at the end of the day, we are a sensor platform. We actually work in extreme IoT environments. That's what we're really good at. We also have a JADO backend cloud. It's called collaborate.org. But here, when I'm telling you about how we can merge our technology. Actually, at Miramar, we can actually show you some really cool stuff. That little soldier down there with the red box actually was on the island at Miramar where we did Patriot Grizzly. So we'd love to actually come and replicate what we did on the tactical R side and SATCOM side and actually do that with you on 5G on expeditionary period of time. Additionally, we've actually made tremendous traction across the military, but also across dual use with Amazon and Emerson. And so you'll find that we're very adaptable dual use. On the next one, what you're going to see here, although my graphic looks bad, it might look bad on your side too, is that there are different parts of the mission that you cannot apply RF to today. Stealth flight lines, bomb dumps, and other areas are still extremely sensitive. Those are requiring transition for many times. You go into training at Camp Lejeune, we were doing heat monitoring, stress monitoring of the soldiers to figure out how they could actually work with inside the thick forest. And we're at 98% connectivity and early warnings to them when they were getting hot. Additionally, when you look at what the opportunities are and the problem sets, is we believe we can apply to multiple of those. On sensor suites, we support over 4,000 different sensors today natively. Biochem, physiological, telemedicine, vibration sensors like in a thermoelectric power plant. Additionally, when it comes to 5G relay, we are a mesh network that scales to 10,000 nodes today, validated across 10CAT Slab Lab and the AFRL. And additionally, we are an LPI LPD network. So we're extremely strong in high metal rich sub-T environments, long range environments, but also we support hot swap capabilities to any other uplink. At ABMS for the Air Force, we did this for forward operating sites, enabling maintenance teams to actually have secure communications disconnectedly, so locally they had it. And then as soon as we get 4G, we pop back up over 4G in burst mode. We also did that in Miramar for commercial SATCOM while Milsat went down. Forward operating, we actually are really good at this. We're swap, extreme low swap. Our smallest device is 7 ounces. You can't even tell that's on the soldier. And also we have other form factors that get you really close to ATAC and operational for ATAC. Additionally, in the hybrid use cases where we think we could shine in the 5G lab is actually working with you across different things like, for example, simple sensors to do security. At Jaybird, they've used us for the ATAC, or do simple aspects about even denied UAVs. We all know UAVs will be denied. Our communication can help them be more resilient, or at least partially resilient into a denied zone. Try that out on the perimeter security. Additionally, Miramar is a great place to do marine, actually island hopping. We'd love to be able to take either a maintenance team, logistics team, have them operate on the base, and then move them over to the Miramar Island to show how they can pack up and go. Extremely lightweight, extremely easy to use, because all they do is turn on a wire like we did at ABMS. We have a lot of potential of mixing 5G together, because we're experts in RF, experts in AI, experts in sensors, and we actually have deployed in some of the harshest conditions in the world. And finally, what we want you to leave with is this. We'd love to cross the line. We've made really good progress with AFWorks, some good progress actually in distributed analytics, over 1,000 nodes with the Army, with no cloud dependencies in our network. We know we can link up to other cloud systems because we've done that, but we don't have any Army or Navy engagement. And we would love to engage with you on that aspect of it, because we are supporting flight lines, we are supporting training, we are supporting health. It is a cross-cutting platform. It makes it hard to understand, but it is very dual use. It's COT-based, open APIs. And as you asked earlier, Colonel, we actually have the ability for mission coders to actually incorporate what they're doing in the austere environment and then bring that back and actually upload that up to the 5G backhaul environment. And so dual use, austere resiliency, we're here to help Verizon. From a company perspective, we are a clean cap table. We have no investors to date, multiple millions of dollars in contracts just in the last year, and we're actually ready to engage with investors.
Thank you very much, JD. We appreciate it. So we're going to pass it back over to our esteemed panel of advisors.
Hey, JD, thanks very much for presenting. Question about your commercial engagements. What are the capabilities that you're bringing in, in the Emerson Amazon examples, or if you want to give a hypothetical just to protect confidentiality, that's fine. But can you just describe those commercial engagements and what capabilities you're bringing them?
Yeah, networks, 5G. I worked for Cisco for almost 20 years, so I know this stuff really well. And what you would see is that there's lots of promise and there's lots of potential in the future, but still in metal-rich environments with high interference conditions, it's still manual data collection when you look at distilleries or thermoelectric power plants. And so what we have done actually with Emerson is networked enabled some of the vibration sensors to do local analytics without any cloud connectivity, but also store and forward that connectivity in the data up into, you could do that in Amazon box. In this case, we actually shot it 20 miles over directly to actually Emerson without any satellite, no cellular, nothing else. And so we can scale or we integrate. And so on that case, we've done that. For Amazon, we actually did exposure health monitoring, very similar to what we were doing with Camp Lejeune.
Hey, JD, thanks for the brief. Just thinking through previous presentations as well as yours, the challenges of both integrating 5G into what we do at bases and stations and supporting all the activities there, but also 5G in an expeditionary environment. In the expeditionary environment, using 5G to replace our communication systems, tactical communication systems, what do you see are some of the biggest challenges that we face going into an environment like that, and not necessarily how would you solve them, but like what do you think about tackling those?
Yeah, so we've actually experienced some of those just in the last 6 months. I'll give you an example. Miramar Island, one of the most expensive SATCOMs for the Air Force just didn't configure. The team couldn't get configured. It takes anywhere from 25 to 30 minutes to configure those. We are instant within 1 minute of actually plugging our wire on. You have an automatic mesh with ATAC, sensor readings, and local communications. And so we validated that. Additionally, though, in those EW conditions, because we can swap out all different antennas, we've done that with Iridium, and we've done that with other SAT providers. Jaybird, we did it with an H860 flying into the valley because the land warriors, although the radios do not work in these really contested environments on the tactical side, nor on the other side. And so we figured out how to actually address some of the really hard challenges, but also we know that we can't do it all. And so we uplink to what's needed and what's necessary. And especially in the EW contested environments, the electronic signature is really important. And also the RF signature is really important. And so we operate at 1 watt. And so we know how to modulate that down even more, or actually relay over out of a contested zone, actually into a friendly zone, or at least an open zone to hop up over a higher frequency.
Hey, thanks for stealing my next question, which was going to be about signature management and emissions control. but
We have
appreciate your answer.
forecast
Thank
by
you.
a SLAD Lab 10 cap we can share with you. And there's some FOUL stuff we've done with forward deployed teams on Air Force we'd happy to share also, but we could also show it at the 5G lab.
Thanks.
So other than obviously you're, exploring opportunities in the commercial arena, do you have a preference as to where you feel you'll like where to focus on to get the most traction and high value for clients? Obviously, it sounds like in kind of inside where the RF is constrained, but also it sounds like there's maybe potential too where there isn't coverage. So kind of in more remote operations within the U.S.
Yeah, and so you've identified. So you look at a couple different things. One is extreme environments. Far edge is still a challenge, and so having analytics actually that our little black box that's 14 ounces, and then our newest version that's 7 ounces. It actually does the analytics processing, it does the sensor integration, and it does the comms, and also the uplinks into other systems. And so you could take a utility worker, for example. When they leave their Wi-Fi connectivity and they're in the metal-rich, high-energy environment, they actually lose their connectivity. And so they want to walk through it. I have friends who used to be with me at Cisco, and they're at Salesforce, and they go, JD, we still get manual data collection for our Salesforce apps in the oil and gas industry. What can be done there? And so those problems are going to exist for a long time to come. And there's actually really good use cases to go try and actually penetrate those through partners, through scaling organizations like partnerships like system integrators, or through channel organizations. And so when we look at the commercial side, we look at where the problem sets are that we can fit really well and try to help them solve that problem. And that's what Emerson and Amazon have done with this. And we are talking oil and gas, but also when it comes to contested issues, pure nations know how to track and detect even military signals. And so when you talk about critical infrastructures in the United States, how do you protect those? That's a great market for us because of the level of security we have in our device, but also the level of kind of emergency response we can do. Puerto Rico has actually rolled this out because cellular towers have gone down in disasters. So we have a 200-mile-per-hour antenna there that actually stays us up for cold chain monitoring of the blood supply. And we only stay up necessarily for the network until the 4G comes back up. So it gives you examples that we want to work with 5G and 4G because it just opens up that ability to bring more data to the cloud, more data to the analytics, but also where there is that kind of emergency or redundancy backup when those don't work. And so there are critical infrastructures, oil and gas, emergency responders, they're just going to need that extra backup or sometimes more resiliency inside of harsher conditions. Hopefully that answered your question.
Yes, perfect. Thank you.
Okay, any last questions for IoT AI? Okay.
If I could,
Okay.
Joe.
Yes, absolutely.
Just because it's IoT AI and this idea of AI at the edge, just thinking through the military applications for AI and sensorizing 5G devices or the battlefield Internet of Things, and then helping present the right piece of information to the right decision maker at the right time, kind of thing. Have you done previous work like that? And then looking at the Marine Corps and of what you know of Marine Corps operations, where do you see tremendous opportunity for benefit doing something like that?
Yeah,
So open,
I'll
JD,
answer the second part of your question. I would say where we can benefit most is in the pack up and go expeditionary forward deploy. Because when you are on base, you need certain data downloaded, you need your services, your C2 downloaded, and then you don't really have control when you go out. And there's lots of different ways to connect. And so at least from a forward aspect of it, we can do for the agile combat, we can give you those connections. We're helping them do the crew. So that's maintenance issues. That's rearm issues. That's actually issues around how to actually just secure perimeter. Those are things we're really good at, but you can use the same technology like Jaber is trying to do across their perimeter because in naturally austere conditions like the mountains and the perimeter of fence, they don't have actually reach, but they want the seamlessness. They don't want to have to switch networks. And so we have had experience of taking ATAC from our device up into the 4G network at Jaber, and it was seamless for them. They didn't need to care about it. They just put it on, they wore it out to the patrol, and they came back, and there was no C2 disconnect for them.
Okay, thank you very much, JD. we are at time. We very much appreciate you, and thank you for joining us. Next up, Calm Sovereign.
Okay, I want to thank you all for the opportunity to present our technology today in 5G competition. Let me start by briefly describing ComSovereign, since we're approaching 5G in a fairly unique way. ComSovereign is a holding company that has acquired several leading microcap technology companies focused on connecting 5G. Our portfolio now includes wireless and optical communications, power, and portable infrastructure. We've developed differentiated technology by leveraging disparate strengths that are not commonly mutually grown. Briefly, our team has more than a decade of experience as a non-traditional contractor for various government agencies. Topics have included software-defined radio systems, as well as developing cellular IoT use cases for DoD applications. Several of our technologies cut across multiple NSIN problem statements. Today, I'll discuss 5G relays and support for episodic networks. Our instant on 5G radio solutions can be combined with portable aerial platforms today. And additionally, in-band full duplex for 5G relay really improves capacity and reduces latency. The following slides will amplify these three highlighted technologies. VNC is a leader in rapid deployable 4 and 5G radio solutions, and these include the radio, base station, and integrated network core function, and thereby supports an independent and autonomous network bubble. The solution is hosted in 2 form factors. One is a ruggedized battery-powered solution called RAID, and supports both dismounted and mounted operations. A second solution is optimized for swap and weighs only a couple pounds, called Featherlight. The Featherlight has been integrated into several UAS solutions, including our own drone products described next. The NFV capability hosts third-party applications, and shown here is an Android application called LifeRing, providing common operating picture software. This is fully embedded within the RAID and requires no external server. And this extends the eyes and ears of the battlefield with functions such as video, a call for fire capability, push to talk, really to anyone and anywhere in the world. Drone aviation complements the VNC solutions with aerial platforms. Tethered aerostats and drones improve wireless transmission range while providing long on-station times. The WASP systems host VNC Featherlight radios to provide instant network solutions in addition to ISR functions. The high ceiling of WASP aerostats improve coverage over temporary tower installations and can operate for weeks. The Watt 200 quad rotor can be deployed in a matter of minutes, and it can operate either from a battery or a generator solutions. Drones Watt and VNC's Featherlight are now fully integrated as a single package solution for airborne 4 and 5G coverage. VNC and drone are complemented with Lexstrom's full duplex capability. Full duplex remains one of those last holdouts and promises to improve both transmission capacity and reduce latency. To get greater than 100 dB of self-interference cancellation, we really require multiple tools and methods operating in concert, and Lexstrom incorporates 3 self-interference domains, including baseband, RF, and at the antenna. Lexstrom's most notable differentiation is the use of its spatial domain processing for post-antenna signal cancellation. The passive self-interference cancellation method is fundamentally different by trying to eliminate the multipath interference before it's seen. With optimized antenna patterns, we have seen an additional 65 dB or better of attenuation in this domain. Coupled with the baseband and RF techniques, it's now possible to achieve the necessary link margins for terrestrial systems. There we go. We request the opportunity to provide a demonstration integrating several of our technologies in a mobile 5G relay compatible with expeditionary force operation. VNC's network bubble coupled to infantry or recon units can demonstrate the use of the COP software for battlefield simulations. To this, we can add an additional aerial asset, such as our tethered UAS, for additional demonstration support and promote greater operational flexibility. We would also like to demonstrate a full duplex system. We would install a link of full duplex test units to the living lab, which can be equipped with surrogate COP UEs. And these would measure and demonstrate both qualitative and quantitative improvements through our operational use cases. We're currently operating only in FR1, but could migrate to an FR2 solution to be compatible with the living lab given sufficient time. While our solutions are capable of operating independently, we also support backhauling to the living lab. These have previously been demonstrated through both satellite and tactical mesh backhauls, and one concept to explore is a patrol group operating COP handsets in an isolated network. This network can rejoin the living lab upon entering or returning to the base or depot environments, and the patrol would be using the exact same UE and handsets in both environments.
All right, Justin.
Yep.
Thank you very much. We have reached time.
That's
Appreciate
good. I just finished. Thank you.
Work together. Teamwork makes the dream work. We're going to pass it off to our esteemed advisors for some question and answer.
Perfect. Thank you.
Thanks for that. That was good. As you contemplate moving from the DoD towards commercial, where do you see the primary use case here? Because it seems like there's a lot going on, and the orchestration is the key, but how you can kind of pull that into the commercial sphere right away.
Yeah, it's a good question. I mean, most of it to date has been primarily first responders, so I won't call it commercial. It's still in the public space, but primarily our traction has been within CBP for the aerostats along the border. Also, a lot of use cases for the backpack and feather lights in typical first responder or emergency response situations, post-disaster, those sort of things. Essentially, where your infrastructure is either knocked out, for example, Puerto Rico, where building towers in a rapid way is not really all that feasible. So you can essentially bring these in, put them up in the sky, and you've got at least a temporary infrastructure in place in minutes.
Okay, perfect. Thank you.
I think I may have two questions, but they're related. So one is the endpoint device RAID, I think it was called, as well as the either aerostat or drone-based tower in the sky kind of thing. Those are all proprietary solutions, or are those you can just use any 5G handset, for example, to connect to that to the aerostat?
That's a very good question. It's an open system, so it complies with 3GPP. So you can go buy a Samsung phone or an Apple phone or whatever. You can use a tactical, ruggedized phone. We've got all of them in our library, if you will, and so our demonstrations typically use all of them and the above. So you can essentially roam with a handset from Best Buy across our network or back into an AT&T or Verizon network.
Oh no, it will be like $150,000 handset that's ruggedized to survive in minus 50 degrees Celsius. But we just don't want to buy 180,000 more of them after we bought the first ones. But I appreciate your confidence in our acquisition system. And then the second question was, I think you had mentioned simulation as part of the capabilities that you would bring. Do you have a modeling in sim or virtualized version of this system that you can experiment with?
I wouldn't say it's a simulated system. It's actually we'll call it a test bench system. It's something we've got both a test range, our own test range, and then we also have a test lab where we run a lot of the experiments.
Yeah, so physical, not a virtualized version.
Correct, yeah.
Got it. Okay, great. And then, sorry, 3 questions, and then I'll stop. The other one was, does this extend the network? Similar to the last brief, I don't know if you were dialed in for the last one, but does it extend the network? Or is it a standalone private network?
No, that's a very good question. It actually, you can operate either way. So the key to it is that the VNC solution can integrate all of the G-Node B and core together, essentially, so you can wander off and be your own network. But equivalently, you can also equip it to backhaul into an existing core network. So we can cut it in a different way, slice it such that we've got our G-Node B talking back, for example, to the Miramar core. And that way, they're essentially collaborative or extended by the virtue of the fact that our base station is connected into the other core. Equivalently, you can also just roam from one network to the other in a traditional way you would with any handset.
Great, thank you.
Dustin, for the virtual netcom product, do you see that, or do you have any plans to take that into enterprise? Any initial traction there, and also any plans to support CBRS frequencies?
That's a very good question as well. We actually are currently supporting CBRS frequencies. That's really our go-to for first market entry as 5G is still maturing. Our primary market for a solution like this is actually a enterprise LTE solution in CBRS. So that's, I would say, where the meat of our effort is going right now, with 5G kind of a development effort to be baked in as the frequencies become accessible for those of us who don't have, accessible licenses.
Got it. Thanks. That's very helpful.
Okay, any other questions going once? All right, well, thank you very much, Dustin. We appreciate your time, and thank you to ComSovereign.
You're very welcome. Thank you for having us. Really appreciate the ability to pitch for you. So thank you again.
Okay, next up we have Python.
Hello, my name is Dexter Ang, and I am the CEO of Python, where we are creating the Gesture Control and Insights platform. Our technology leverages high bandwidth neuromuscular signals on the surface of the skin and machine learning. We are a 35-person small business based in Boston. We have expanded the range of problems we seek to address from the original goals that focused on increasing the independence of individuals suffering from ALS to our engagements now with warfighters. The DoD has a national defense mission need in the area of soldier lethality for multi-domain operations. Soldiers need situation awareness and human-machine interface solutions that are quick, intuitive, and effective, and can be used during any phase of operation during day and night and without interfering with the use of weapons and tools. We have engagements with multiple customer groups and are on a path to be integrated with programs of record for TAC and Air Force Special Warfare. As you can see, this is our technology on the wrist. It is shown a visualization tool that demonstrates our machine learning SDK, as well as our IMU gyroscope data. And so this development platform can be used by end users and partners to be able to understand physiological impacts. Our patented sensor has 5 patents and 15 pending, and we can create essentially a soldier as a sensor. Our device on one wrist even generates 12 gigs of data a day. We have conducted preliminary research to enable detection of features such as a trigger pull as a source of data to amplify both mission and training effectiveness. Knowing when an operator takes a shot, where they were aiming, how many shots they fired can all serve as key inputs to direct attention to threats in the timeliest manner. We have also performed studies linking neurophysiological state in the brain to wrist-based signals. This data can be streamed over battlefield networks to central servers. Understanding the current health of the operator can help provide a real-time estimate of force readiness to inform battlefield commands. Dude, I'm trying to go backwards. Slides are out of order, no problem. In conjunction with our special forces customers, we have built tangible prototype capabilities for all of the use cases shown here. Headset interfaces, drones, marking targets in TAC, human-machine teaming, and haptic alerts. By simply lifting a finger, an end user can perform tasks on a 5G network, all while remaining heads up, eyes out, and weapon ready. 5G will become the primary comms method on bases in the PACE architecture. In a similar manner, Python and our government customers have realized that intuitive, discrete, and platform agnostic gesture can serve as the primary mode of interaction in a PACE architecture, supplementing existing methodologies. As we lay out our vision for making the biopotential electricity in humans visible in the world, we have engaged several early partners. Our customers include NSW and Army Special Forces. We are one of the top 21 companies in the Air Force Strategic Cyber Program, which calls out for us 2 programs of record, BATDOC and SWAC. Our commercial customers include Google, Boeing, and Samsung, whom Python is an official partner for their Tactical Edition 5G phone. Our strategic partners include In-Q-Tel, representing the intelligence community, and Bose, representing consumer electronics. As Python's technology transitions to integrate with different systems, it will permeate the battlefield to both amplify security forces and dismounted soldier survivability, while providing a unique source of insights into real-time force readiness assessments. We see the potential for Python gesture and insight to support 5G applications for every single person. Our team includes seasoned executives from software, prime contractors, and hard tech. My background is in mechanical engineering, signal processing, user experiences, and our team at Python is creating the next generation of gesture control and insights platform for 5G. Thank you.
Okay, thank you very much, Dexter. I appreciate that. We're going to pass it off to our team of esteemed advisors.
Hey, Dexter, Carl Pugh here. So cool technology, certainly, reducing the cognitive burden on the operator is always desired, as well as, sensorizing things that they can't even report back because they don't understand what's happening, although you can sense it. So it looks like this is much more about something to take advantage of 5G than something that is inherently 5G itself. What is the link right now? How do you collect all that data now? Is that through Bluetooth to a handset or something?
That's a perfect question. Thank you for asking. And so our sensor is worn on the top of the wrist, as you saw, and I have one here if you can see my image. And so yes, this device acts as a dumb sensor over Bluetooth Low Energy to any Bluetooth enabled device. We have hardwired options for users who need secure networks. But then yes, the endpoint is an Android phone typically, and it could be typically a Samsung phone or another phone. And then we can interface with any sort of cloud or local area network.
So using 5G, all of that data from all the users, all the devices that are out on the battlefield would be streamed back to some central place where they'd be interpreted by what's happening with the individual as well as their interaction with the battlefield and other information. Have you thought about the back end, or do you have some sort of application or solution for that back end piece?
That's a wonderful and complex question, to be honest. And so depends on the customer. Our work with In-Q-Tel does revolve around data collection, and these particular customers don't want a automatic background service backhauling it. But we do have customers who do want the automatic background service uploading it to cloud in real time for a central TAC server, for example. I'd say that the architecture depends on the customer, and we try to stop at the phone. We try to stop at the phone, and we allow the capability for the end user to toggle. Do they want to be real live streaming every single bit of our 12 gigabits a day, or do they want to be batch uploading at night, for example, or offline in a squadron manner? And so right now, that's how we've built out the architecture.
Great, thank you.
Dexter, I'm just wondering about resolution. Could I, for example, wear one on each wrist and use a virtual keyboard? What sort of gestures can you recognize, or how fine a gesture?
That's a wonderful question. And so where we have determined the most important benefit to our end users, whether it's a dismounted operator or it's a factory worker, which is our enterprise product offering, is actually to reduce cognitive load. Therefore, we want our system to be as simple as possible. And so we have designed what we call our library of gesture primitives to be very intuitive and consistent across all applications. They include things like lifting your index finger up and down, swiping your thumb, left or right, and then combinations of those two with gross movements of your wrist. So basically the use cases and gestures that a person would need to know are really just two: lifting your finger and swiping your thumb, and then, for example, swiping across your phone, but no phone doing it in the air. So our goal is to provide the simplest possible solution for end users.
So with the index finger, would that need to be on the arm, or is it translatable across? I guess that was kind of the same question. Forgive me if I didn't.
Yes. So currently we're focused at the wrist. The wrist is quite an important area of the body. And currently we focused on users that have one. However, two is not a problem. We've actually had users where up to four. They were very interested in the whole body's physiology and human performance side. And so why is the wrist really important? It's because your hands are actually the endpoint for nearly half of your peripheral nerve system endings. And so if you create essentially a toll gate at your wrist downstream, we can capture all that traffic going to your hands. And we have a rich set of data that is able to infer human performance, such as anxiety, such as grip strength, as I mentioned, trigger pulls, in addition to our gesture control capability, which is getting quite a bit of interest for the emerging field of IoT sensors and autonomy.
Thank you.
And Dexter, I imagine you just have a very basic processor in the wrist unit. Is that right? So you should have a pretty low BOM cost.
The BOM cost right now, great question. We've shipped 120 units primarily to soft customers this year. We are in the prototype mode. Next year, we anticipate to be having an order of magnitude or more of our shipments. And then also our BOM cost right now is sub 120. And we anticipate, depending on the form factor, being able to go down to less than $30.
Okay. Any other questions for Dexter? Okay. Thank you very much, Dexter. We appreciate you and Python. All right. And last but not least, we have Kumu Networks.
Hi, everybody. My name is Aditya Agrawal, and I'm with Kumu Networks. We're going to talk about 5G relays and repeaters with interference cancellation to extend the range of 5G. So Kumu Networks is about 8 years old, and we are the enabler of full duplex radios. We pioneered the technology in Stanford University about just before that. One of our founders is here, and he'll be here to answer some of the Q&A, deep technical guy. So this is a game-changing technology, and with applications in multiple domains, commercial and military. And on the DoD side, on the right-hand side, you see our track record. We've supplied an interference cancellation module for 130 dB of isolation for Army CERDEC, and this project was called the NSC MFDR program. We have an experienced management team, and we're a startup, about 30 people odd. But we have an experienced management team and strong investors. Verizon Ventures is one of them. Cisco and NEA are a couple others. And we are, of course, a US-owned and top-tier financial supported company. Our core technology is self-interference cancellation. So we cancel interference between any two radios, waveform agnostic, there's two tiers of cancellation that we do: analog cancellation and digital cancellation. And then there's antenna cancellation. So in the MFDR program, I said is 130 dB of cancellation, and this is the most cancellation out there in the industry. We also have a feedback signal which controls that cancellation real time, so it can tune to channel variations. Now, this is not in the RF path, and therefore, the insertion loss in the system is limited as a result of that. Some of our products, so we started our journey some time ago. So we have modules like I just showed you. We have also chips that we have shrunk that module down to like a chip, a small little chip, actually, most of that. And so we have actually gone down the commercialization path. And then we've used those chips and modules. And then in the back here, you see our 5G repeater prototype here that we would greatly appreciate the opportunity to bring to the test bed in Miramar Lab. Now, this is something that we've already tested with Verizon in commercial networks, and this is an FR2 repeater in 26 gigahertz, 28 gigahertz. And we're developing a relay as we speak. So there are two different options for range extension in 5G, I would say the main ones, relays and repeaters. And relays are called IAB in the case of 5G. And there are some trade-offs. And in this case, we think that the repeater has certain advantages in terms of very fast turn on and turn off time, so that you can just turn it on, do your job, turn it off, and it's very fast. It also has a lower complexity, lower cost, lower latency, but it has some disadvantages in terms of amplifying noise. We do both. Right now, we have a repeater we'd like to test, but that's where we are at. Now, why interference cancellation? So in the case of repeaters, if you don't have interference cancellation, the gain is very limited. You can get maybe 65, 70 dB of gain. But with interference cancellation, you can cut off the interference the receiver is seeing from the transmitter and increase the gain by 30 dB or 40 dB, and that increases the range by more than 2x. Relays have a similar set of advantages, and I won't get into this. Now, we have analog and digital cancellation, but in the case of FR2 5G, we have really been able to just do this just using digital cancellation, which is great because it means that we can actually, whatever you can do in digital is obviously ideal. We can do analog, we can do many other things, but we actually have been able to successfully do this using digital, and this prototype shows that. These are some measurements without getting into results, 100 dB gain with cancellation, 72 dB gain of the repeater without cancellation. And this is more screenshots of that. And again, in the interest of time, I won't get into a lot of detail here. With cancellation off, the repeater actually oscillates after a certain amount of gain. Okay. This is some Verizon 5G live measurement results. You see that the purple is with a standard repeater. The blue is the range extension with our repeater. And this is more in different Verizon test live network. These are summary of test results we can get into in terms of Q&A, where the deployable region can increase quite a lot. And then finally.
Okay, we are at time. Thank you very much. I know you have some Q&A coming up with our esteemed advisors, so I'll turn it over to them and feel free to engage with them.
Thank you so much.
Aditya, Colonel Pugh here. I'll go first. Just asking about the military problem that you are trying to solve that may be unique from some commercial applications. So certainly lifting and dropping best practices or commercial technology onto the military is good. Do you see any unique aspects of military application where your technology would provide us an advantage?
So in general, we are using, so in the case of military, range becomes an even more important problem. And then quick turn on and quick turn off becomes a very important aspect as well, is what we think. So our repeater is able to do both of that very effectively. Now, can it be useful in the commercial domain? It's useful, but not as useful. And we find that in the military, I think that usefulness increases quite a lot.
And just to add to that, ease of deployment is critical in mobile military scenarios. You're basically putting a pole up on a truck and moving it around. That's the kind of use case where having a repeater with two antennas that are close together and very little isolation between those antennas becomes useful. In commercial deployments, often people can get around that isolation problem by placing antennas far apart, but in a mobile military setup, that won't be an option.
I'm glad I asked that question. You got to the slide that you weren't able to get to, and that was, yeah, that's an insightful answer. Thank you.
Yep.
Yeah, Aditya, in a commercial 5G network, who is your end customer? Is it the base station or small base station manufacturer, or do you go in through a network operator? Can you just talk about that engagement model?
It's so our end customers are our direct customers, typically, somebody who's going to build the equipment. It can also be the operator. So the case that you see on the screen is of an LTE relay a full duplex LTE relay that we currently supply to a tier 1 US mobile operator. And so in this case, we are engaged directly with the mobile operator. But, in 5G, it can be either. And in 4G, it can be either. It could be an OEM, it could be the operator. So we do both.
Great, thank you.
As you look towards deployment, what do you see as the biggest kind of, I don't want to say bottleneck, but because I mean, in a perfect world, this is fantastic, right? This is kind of the holy grail for spectrum, right? You get the most out of it. So yeah. What's the limiting factor that you see that kind of might slow down adoption?
Mayank, you want to take the first crack at that?
Sure. So in the 5G use case, it's to some extent it's timing. People are already deploying networks. So, we are at a prototype stage. We need to get to a product stage that we can deploy quickly. So to some extent, we are a little behind on the timing of a solution. That said, we are hopeful that the significant benefits that the solution brings to the market would kind of compensate for the timing. In the larger kind of use case where we extend this to relays, a lot of it depends on how very we get integrated into somebody else's box. As Aditya mentioned, one of the best outcomes would be integrating this technology in an OEM box. Typically, those are longer design cycles, which becomes a challenge. So initially, we've kind of sold directly to carriers, but eventually, from a commercial point of view, integrating into OEMs would be the right solution.
Perfect. Thanks.
Any other questions?
Any other questions? Going once? Okay. Thank you all very much for helping us out, Kumu Networks. We appreciated your presentations, and thank you very much.
Thank you so much. We're looking forward to an opportunity to demo this.
Okay. So we will go to a break. Right now, I want to make sure that we thank the advisors, Michael, Jeff, and Colonel Pugh. We really appreciate your time that you have put into examining this technology, helping us move the 5G mission forward. We also want to thank our companies. I hope I still have friends after this gig, but we had a great time and everyone participated and put together some fantastic presentations. So I'll also remind everyone of some of the next steps. We are going to go into the judging and deliberation period right now. We'll be taking a break of no less than 5 minutes. And the winners of this will receive a $50,000. They will also be able to pilot their wares in the 5G Living Lab, and then also receive support and credits from AWS. So we're very excited, and we will be back in no less than 5 minutes. Okay, and we are back. We want to thank the judges and team for helping us out, and we want to make sure that we send you all out in good fashion with some great news. So I am here to introduce Alex Phipps, who is the Deputy CTO for NAVWAR. He has been a great partner for us and also the NAVWAR NIWC Pacific team. So everything from deliberations to strategy to helping us understand what the need in the military and defense was. We were very happy to have them on board. So with that, I'm going to turn it over to Alex, and he's going to have some talking points and tell you who has come out of this with some new swag.
All right, great. Looks like I'm on. So it's definitely been my pleasure to be here today with everybody. I wanted to acknowledge and congratulate all 10 of the companies who pitched today. It was a great job by everyone. Really impressed to learn about all the new technologies and all the new areas that folks are looking to support the DoD and our national defense. So as the Deputy Chief Technology Officer for NAVWAR and the Chief Scientist at NIWC Pacific, I get to announce the winners shortly. Before I do, I wanted to give some additional background on our command and highlight some of our partnerships in this pitch event. So the mission of the Naval Information Warfare Center Pacific, or NIWC Pacific, is to provide concept to capability via research, development, engineering, and support of integrated C4ISR cyber and space systems across all warfighting domains. So what this actually means is that our footprint in the information warfare arena includes an array of diverse technologies, ranging from communications and networks to unmanned vehicles, artificial intelligence, and quantum science. And of course, this also includes 5G. NIWC Pacific is located in sunny San Diego, California, and is currently the only DoD lab headquartered in a major fleet concentration area. This allows for direct interaction with our stakeholders in the fleet, as well as opportunities to connect local companies such as those featured here with our naval mission. In addition to San Diego, we have satellite installations in Hawaii, Japan, Guam, Philadelphia, and other strategic locations. In terms of size, NIWC Pacific has a total obligation authority of nearly $3 billion, and our workforce currently includes over 5,000 civilian employees, comprised of scientists and engineers, technicians, administrative, and support personnel. Additionally, we have approximately 200 active military who directly support our mission. Our highly credentialed and highly educated workforce includes over 200 PhDs and nearly 1,500 master's level teammates. For the past 80 years, NIWC Pacific has supported the Department of Defense with research in lasers, underwater acoustics, AI and machine learning, radar and satellite communications, and we're even an early adopter of the ARPANET, which many of you may recognize as a precursor for the internet. Much of our success would not be possible without partnerships from both academia and industry. We work closely with both local colleges and universities, like the University of California, San Diego State, as well as other institutions across the nation and internationally. With industry, we maintain an annual portfolio of more than 50 cooperative agreements and actively promote pathways to license NIWC Pacific intellectual property with both government and commercial use. Recognizing the importance of 5G technology, NIWC Pacific, in partnership with our sister command, NIWC Atlantic, is at the forefront of the DoD's efforts to ensure that 5G technology is scalable, secure, and operationally relevant. We're actively growing a 5G workforce to include new professionals, domain experts in software-defined radio, software-defined networking, cybersecurity, non-terrestrial comms, and mobile device security. My personal technical background is in hardware, and for the past 10 years, I have been performing and supporting research in novel materials and circuit topologies, both of which are enabling technologies for 5G and beyond. So technically, today, everything I have found to be very, very interesting and intellectually stimulating. Directly supporting the Department of the Navy's CIO office and shaping the current and future 5G efforts is a key task for NIWC Pacific and NIWC Atlantic. Current efforts include installations at the Marine Corps Base Camp Pendleton, as well as the Joint Base in Pearl Harbor. Both efforts currently leverage the Information Warfare Research Project Other Transaction Authority vehicle, which is quite a mouthful, but this is a special non-FARS contracting vehicle with the goal of helping us to go fast. If there's interest in that from the community here, you can Google it. It's the-iwrp.org. Engaging in 5G, NIWC Pacific has been engaging in 5G R&D and prototyping with a variety of DoD organizations, including Pacific Command, the Office of Naval Research, DARPA, the Undersecretary of Defense for Research and Engineering, and additionally, we've been funding a good portion of our own internal research on IRAD money. So I think a lot of this shows the importance that we are putting into the 5G technology space. NIWC Pacific and NIWC Atlantic are participating as key members of multiple federal groups and standards engineering bodies, including the DoD 5G standards cross-department team and the Federal Military Group. Additionally, we're involved in policy evolution and the soon-to-be released updated streamlined broadband deployment policy, the DoD 5G strategy, the 5G implementation strategy, and a number of other General Accountability Office studies. Our team at NIWC Pacific, led by Marissa Brand, has been supporting our Marine Corps partners at MCAS Miramar for some time now. Our team has been providing technical experts to help advise the Marine Corps and support the development of the 5G Living Lab. NIWC Pacific researchers are playing key roles in advising and evaluating 5G applications for both the Navy and Marine Corps. Our technical teams will continue to play a critical role in supporting these efforts and the larger DoD-wide 5G efforts. So I wanted to thank everyone at our NIWC Pacific team, the National Security Innovation Network, the folks at NavalX, MCAS Miramar, as well as the Office of Naval Research for making this event possible. Now the moment everyone has been waiting for, the results of the NSIN Starts 5G pitch competition. After much deliberation and consideration of all the great technologies pitched today, the 4 winners that were selected for this pitch are Com Sovereign, Gen X Com, Omnispace, and V Rotors. Congratulations to you all. We look forward to seeing what you can accomplish as you demonstrate your technologies on the base in the Living Lab. Thank you.
Okay, thank you very much, Alex, for that. And we congratulate all the winners. Very excited. So I want to thank you all for joining us today. It's been a fantastic day with lots of participation and wonderful ideas from all across the country that are going to help us move our 5G strategy forward. I want to encourage you all to stay in touch with NSIN at our website, nsin.us. Also interact with us on social media when it comes to Facebook, LinkedIn. I think we have an Instagram too. I use social media more at work than I do for my personal life, so excuse me. And we will have a recording of this video put up on NSIN's YouTube channel, and also will be on our Defense Innovation Network. So feel free to stay in touch, and we thank you for your participation in this event. Have a great evening.